Have you ever noticed, in a Fibonacci style sequence, the sum of the first and fifth terms are always 3 times larger than the third term? Why is this true, and can you show this using Cuisenaire rods? Okay, let's do a nice visual proof of this then using Cuisenaire rods. So let's say the first term of this sequence is this yellow rod here, and the second term is this red rod. And we could have chosen any two rods we want to do this. Now the third term is going to be the sum of these two rods together. So let's add together a yellow and a red rod and we get this. Now the fourth term will be the second and the third term added together. So there's the second term and let's add on the third term and we get this length here. And then finally we need the fifth term, so I need to add together the third and the fourth term. So there's the third term and there's the fourth term. And if we add those together, I get this long length up here. There we go. So there's the third and the fourth term added together. Now we're saying that the first and the fifth term is 3 times larger than the third term here. So if we just move the second and the fourth term out of the way just for a moment, you can see this is the third term. And if I add the first and the fifth term together, you can see it's exactly 3 times larger than the third term here. So it's a nice introduction into algebraic proof, which we can go on to now. So for me, one of the key strengths of using visual proofs like this is that it gives pupils a gateway into a more formal algebraic proof, and it helps them make sense of it. So let's call the length of this first rod y. So the first term is y, and the second term would be r. And then it's kind of obvious that the third term is just going to be the length of the yellow plus the length of the red, which we can write as y plus r. And then what about the fourth term then? Well, I need to add together the second and the third term, so it's going to be 2r plus y. And what we're actually doing here is we're collecting like terms, although it just makes perfect sense for the pupils. The length of the red plus the length of another red will be the length of 2 reds. And then the fifth term here is obviously going to be 3r plus 2y. Now what happens then if we add together the first and the fifth term? Well, we've already got 3r plus 2y. If we add another y to that, we're going to end up with the expression 3r plus 3y. And how do we formally show that this is 3 times the length of this middle rod here? Now, well, using a proper algebraic proof, we would now factorise this out. We can grab the rods though. So here's the fifth term, and let's split it into yellows plus reds. And we're missing this one yellow here, which comes from the first term here. So we can factorise this expression out to give 3 lots of red plus yellow, which is now a formal algebraic proof to show that the sum of the first and the fifth terms is 3 times the third term.